Hi, and welcome to the Data Wranglers, a conversation about the latest trends in data engineering, hot takes, and insights on the data industry. I'm your host, Joe Hellerstein.
And I'm Jeffrey Heer. And I'm thrilled about our guest on today's show, Mike Bostock. So Mike has an incredible resume. He's the creator of D3, founder of Observable, and on a personal note, my former PhD advisee when we worked together back at Stanford. But before we get into it with Mike, Joe, I know you largely work in the world of databases, whereas, I spend a lot of my time in the browser thinking about data visualization and communication. But recently, those worlds have started to collide in interesting ways. And it's just one example I saw recently. DuckDB, an in-process database, has now been compiled to WebAssembly. So this is to get high-performance analytic SQL in the browser or in Node. And so who knows, maybe JavaScript really is the next platform for data science. And that's maybe something we can touch on with our guest today. And so I'm really excited to welcome Mike onto the show. And as I said, Mike is the creator of D3, a former graphics editor at the New York Times, and founder of Observable. Mike, welcome to the Data Wranglers. Thanks for joining us.
Hi, everyone. It's great to be here.
Mike, it's been a while since I've seen you, and it's really fun to have you on the show. Welcome back.
Thanks.
In brief, D3 is something I think everybody's heard of, but maybe you could give us an overview of what is D3. Set the stage for us.
Sure. D3 is an open source library in JavaScript for data visualization on the web. It has been around for about 10 years. I think now we just won this 10-year Test of Time award from the IEEE, which I'm really proud of. It's been a long effort, I think. So some of the things that are distinctive about D3 is that it is a very low-level abstraction for visualization. I think sometimes it's been characterized as kind of the jQuery of data visualization in the sense that it's really oriented around the document object model, kind of the standard scene graph for representing graphics in the browser, using SVG elements primarily. And how can you manipulate those elements to correspond to data? It also tries to incorporate sort of a number of useful visualization abstractions within this framework. So you've got things like scales, which are for mapping abstract data into visual encodings. And you've got things like layouts for sort of computing common positional arrangements of graphical elements. So things like trees or tree maps or force-directed graphs and that sort of thing. So it gives you really like a whole suite of these low-level primitives that you can then compose to kind of make any visualization you want. And I think people have always appreciated that sort of expressiveness to it, the ability to kind of do whatever they want and take it wherever they want to go.
You mentioned that the original paper won that 10-year Test of Time award, which is super cool. Everybody wants to build a software package that will be beloved and last that long. What's the secret? What do you attribute the success and longevity of the project to?
Yeah, so I think there's a few different things. So I think one is really like an environmental factor, kind of right place, right time. I think, before D3, there was a lot of work that was being done in Flash to do interactive graphics on the web. And really like being able to do interactive graphics in the browser was kind of coming of age, 10 years ago, something like that. You were finally able to do all of these things. Funny enough, I think it was 1999, I was an intern at Netscape and I wrote my first visualization library in JavaScript, and that predated Canvas and SVG, and so everything was done, I think, using table elements and like invisible 1-pixel GIFs that you would resize in order to get the layout. So you can imagine all the headaches there trying to do graphics without a proper graphics API. So I think, you had this environmental factor of finally being able to do this type of work well, like robustly, like expressively inside of the browser. And then, of course, together with the explosive growth of data, the demand for data visualization to help people understand, this world around them in data. So I think there was a lot of demand and interest in finally the capability. The second thing that I think I would mention, and I touched on this before, is kind of this unboundedness or the expressiveness of D3. So in a sense, like you weren't giving anything up by choosing D3 to do your visualizations. Like there wasn't a risk that you wouldn't be able to do something. Whereas a lot of the other, visualization abstractions that existed, you typically run into some constraints, some limitations in terms of what you can build. Like there's this trade-off where you're choosing to get, this expressiveness or this efficiency in the ability to make your visualizations quickly, but the trade-off is you can't do as much as you might want to do. It's enforcing some constraints or limitations on your design. And you generally don't run into those in D3. It just gets kind of progressively harder the more and more that you want to do with it. I think the last thing that I would say was a big contributor to D3's success over time is really all of the examples, and more generally the support. Sometimes it's hard to even decouple those things, like how much of D3 in people's minds is the library versus the suite of examples. Because we did put so much work, over the years into building out those examples. I mean, I think there's more than 1,000 of them that I've worked on. Now, a lot of them are in, observable notebooks, and we maintain several hundred of them. And I think for a lot of people, it's not just the library. It's what are the examples that I can use as a starting point for doing my work, and then sort of, tweak it as I need to, as I want to take it in a different direction.
Yeah, that is such a huge lesson for everyone building open source. And I know that I've heard anecdotes of people crawling the web for data visualizations, and some crazy percentage, over 50%, were basically from your gallery.
It is pretty crazy. I think it is a very successful pattern, to have this starting point where you don't have to build everything from scratch. You can just sort of start tweaking things and see where it goes. That said, I do think there are some downsides to this approach as well. I think one of the biggest challenges with visualization is that you don't really know how well the visualization will work until you get your own data in it, right? So you see an example, you see a visualization, you're like, that looks like a good visualization. I want that for my data. It takes a bunch of work for you potentially to get your data into the right format that you can fit it into that existing example. And so in that sense, you're already invested in that form, at which point you realize, maybe it isn't actually that effective at, communicating or finding the insights that I want. And so I think over the years, as I start to understand a little bit more about visualization and sort of these common use cases and stuff, I've started to gravitate more towards the higher level abstractions as well. That gives you that more flexibility to try out different things.
So maybe let's jump into that. There are a bunch of these higher level abstractions, some of which seem to be pretty popular. Jeff has this Vega Lite library that his lab built. You have observable plot. Is D3 become sort of the assembly language and we move up the stack, or what's the future for this ecosystem?
I think that's not a bad way of looking at it. I mean, I think at one point we referred to it as the visualization kernel, or the standard library of visualization and that sort of thing. And it does have that feel in the sense of being a very low level abstraction, these suite of tools that are generally decoupled but sort of work together harmoniously, so you can sort of pick and choose the pieces that you want. And a lot of these other higher level visualization libraries, grammars, whatever you want to call them, they are built on various parts of the D3 sort of suite of tools. They might have D3 scales in them, they might have D3 layouts, that sort of thing. So observable plot, for example, is built on top of D3 and uses a lot of those D3 components internally, even though it's not sort of exposing the low-level D3 abstraction outside of plot. So for me, I think my motivation working on things like observable plot is really trying to, help people see kind of as many visualizations as possible in a given window of time. And I think by seeing more things, you can get to a better result. We're all time bounded in terms of how much work we have to sort of spend exploring. And if you can see more things, usually you can get to a better place and get to a deeper insight or get to something that will communicate more effectively. And so it really, as much as I loved using D3 in the past to do some of that exploration, and obviously being very familiar with the library, I was able to use D3 for exploration. But even so, having something like plot made me realize how many more things I could see even with that familiarity by having that higher level of abstraction.
Yeah.
So along the way, you also worked as a graphics editor at the New York Times. And so I'm curious how that fed into the lessons that you've learned here. So well, in terms of, arriving at successful visualizations and how to publish them out to the world, what did you learn working at the Times?
Yeah, I mean, I think one of the big things is just the wide range that you have in terms of visualization applications. Like they're not all the same. We talk about the spectrum of exploratory visualizations to explanatory visualizations, which I think is a big part of it. But I think, the New York Times style of work, the very sort of high cost, polished, bespoke visualizations are very inspiring, and they can be very effective at communicating, to a wide audience, even like very nuanced patterns and data. But I think it's also important to recognize that they're very expensive to create. They take a lot of time, they take a lot of expertise. And one of the things that I'm trying to do more with Plot, for example, is to try to make, visualization more commonplace, more ubiquitous, more everyday. Like, I don't want it to be treated necessarily as this very precious thing that can only be done in very sort of special circumstances by, full-time professionals that are willing to invest a huge amount of time. Because I think it's just like, it should be kind of taken for granted in a sense, like part of our common language of how we work with data, how we communicate these quantitative insights. Like, I don't want it to be this very precious thing. So I think there are times when you do need that sort of high level of work and the bespokeness to communicate something really effectively. But you also need, the fast, the quick and dirty sort of charts that just help you see something quickly as well. So there's that whole spectrum there, and I'm a firm believer that there's not one ring to rule them all, right? There's a lot of different tools that you're going to want depending on sort of where you are in the spectrum, and hopefully they have some sort of shared representation so that you can transition between them easily, or shared concepts, but not just one tool. I think it's great to have multiple tools.
Yeah, your comments remind me of some aphorisms I once heard from Pat Hanrahan, for example. Like, the most valuable visualization is often the one you create in a second and you can throw away in a second because you got the insight that you need. Coupled with that, 90% of the time that visualization may be a bar chart.
Right. It's funny, actually. So bar charts, they're certainly very popular. One of the things that I've been dealing with Plot, so we use this kind of grammar of graphics abstraction, similar to Vega Lite, and we have a bar mark in Plot. But for observable Plot, the way that the marks are designed is they imply aspects about dimensions of data that are associated with those marks. So there are two bar marks. There's a bar Y and a bar X, which is sort of your bar Y are your vertical bars and your bar X are your horizontal bars. So for a bar Y, the X dimension is ordinal. So you'd have like names or categories, and then the Y is quantitative, right? Like a number, a value, that sort of thing. But one of the most common things people want is a time series bar chart, right? And in a time series bar chart, X is not ordinal, usually. It's more of a temporal dimension or quantitative continuous dimension. And Y is still quantitative. So if you wanted to plot like, temperature over time or like trading volume over time, people often reach for that bar mark because they're thinking, oh, I want a bar chart here, but it's implying something wrong about the dimension of data. So it's interesting, like switching people to like, oh, you want a rect in this situation, which is for quantitative dimension rather than ordinal dimension. It's just interesting that the language that people have and sort of the gap sometimes that forms between the words that you use in tools versus what people use in common language. It is helpful to have like a lot of specificity, I think, in these terms, but there's sometimes a challenge when the tool is like overly specific in what it's saying about the data.
Yeah, interesting. Yeah, I think in Vega Lite, a bar will cover all of those conditions, including ordinal and quantitative axes. So I agree. All of these little minutia of tools that may seem, insignificant to an outsider end up being, quite interesting in terms of people's everyday workflow.
I think tools are most valuable in terms of providing a representation, like a way to think about the problem, and sometimes it can be challenging to introduce a new representation because it's different than what people used before. But if you can get people to sort of shift their perspective, then I think that's when the transformative things, like the things that really unlock productivity and getting more people to be able to engage in this sort of practice start to happen. I think with D3, for example, one of the challenges was, of course, the data join, which was one of the core concepts of D3 of how do you sort of take a array of data and turn that into an array of DOM elements, but not just once, like not just creating a visualization from scratch, but like when you want to update it and you might want some sort of animated transition and things are entering and things are exiting, how do you do that sort of thing? But of course, a lot of people came into it and they were just like, I'm not interested in that animated transition stuff. I just want to make a static bar chart. Why do I have to learn this like elaborate, data join, select all pattern in order to get that work done? But I think once you kind of wrap your head around that, you understand that like you can go from that static bar chart into something that supports those animated transitions. And that's really powerful rather than sort of being permanently stuck with just doing static visualizations.
I think one of the things I find really interesting here is you guys are basically talking about language, and I mean that like in the human sense as well as the computer sense. Like if you need words for concepts, right, and you need to agree on the words, and communication between the person and the library is language design. Little languages are easier to learn than big languages, and of course little tasks don't need as much language. So learning hungry, angry is less hard than learning Mother, I'm feeling nostalgic. Saying so it's just really cool because you guys are essentially both tool builders and language designers. It's been really fun watching the languages for these libraries, especially the not just the static graphics, but the interactive and animated graphics. The languages that you two have been designing are really cool.
Yeah, I mean, I think the languages are abstractions themselves, right? Like they're not code abstractions. They're not these like hard formal things that are understood by a computer, but they are like ways that we kind of take these complicated concepts and kind of compress them down into a single word or term that we can then sort of refer to again and again and again. And it almost gets processed like subconsciously after a point, but it is helpful for us to talk about things or to think about design spaces or ways that we could explore.
Yeah, there's a graduate lecture on semiotics in computing that we can do after this poem.
Mike, your current effort is Observable, right? A platform for collaborative, web-based computational notebooks. So you can tell us, how did Observable come about, and what are you trying to accomplish?
Yeah, a big part of Observable is trying to figure out how we can make this practice of data analysis and data visualization sort of more broadly accessible and practicable. We saw a lot of interest in people doing data visualization with D3, and I had built this platform called Blocks, which was really just a way of sharing examples for D3 that were backed by GitHub gists. I was building a lot of examples for myself. As I think I mentioned, we had like about 1,000 different examples that had been developed over time and maintaining. So I wanted something that was scalable, that made it easy for me to sort of publish a new example and share it on Twitter, share it with the world. And also making it easy for other people to sort of fork those examples and to tinker with them and share them. But even with that sort of platform, I think one of my realizations was just how many different technical hurdles there are to get people to learn D3, to do data visualization. And I wanted to think about sort of how to make that more accessible, how to make it easier for people to understand sort of how to write code that is needed to produce an interactive visualization, but also thinking about sort of how people collaborate, right? And how can we sort of make it easier for people to share their techniques, make it easier for them to share their code, to reuse that code. And so even having like stuff on the web is a huge leap forward than just doing sort of development in your local desktop environment. But there are some other things about, like making it easy for people to tinker with the code without having to, sign in and create an account. That's one of the aspects of Observable, is where, you can't just read the code to understand what it does. Often you need to tinker with it. You need to break a few things in order to figure out really what this code is doing. And so having that kind of tinkering as part of our philosophy, I think helps understanding. And also things like, importing. So in Observable, you can any cell that you create can be imported into another notebook. So it's really easy to transition from sort of a one-off visualization into a reusable component that you can then pull into other notebooks and use again and again. and you don't necessarily have to sort of do the heavy lifting of turning it into a bona fide open source library that you're going to publish to NPM and do semantic versioning and all that stuff, making it more a gradual transition.
So, I love that perspective of sort of a developer and a software engineer's view on what notebooks should be. Maybe you can talk a little bit about what makes an observable notebook different from the notebooks that many people are using for data science.
Yeah, I think the most interesting thing for me is that it is a medium for thought, a tool for thought, for communication, for understanding, rather than just sort of a script that's getting the computer to execute some sequence of instructions and produce some output. So what I like is having that ability to combine code with prose, with markdown, with images, with interactive images, with inputs and that sort of thing. So it's a very rich kind of mixed media canvas where you're pulling together a lot of these different elements so that you can sort of have the ideal environment for your own understanding, like your own exploration, but also for communicating whatever it is you learn to somebody else. So part of that is whatever specific insights that you want to share with somebody else. But it could also be about sort of the process of analysis. Like, how did I perform this analysis? How did I construct this visualization? What I want is for the internals of that process to be transparent and accessible to whoever the recipient of the analysis is. So I think one of the things that we know is that, every time you do analysis, it's not the end of the story, right? It's always going to raise new questions, and you're going to want to repeat that analysis, maybe with some different assumptions, some different data. Maybe you're just doing it again 3 months later, that sort of thing, or you have different teams in your organization and they really like that type of analysis, and then they want to apply it to their own problems or their own domain. And so thinking more broadly about that sort of social process, like how does data analysis fit into the sort of social structure of organizations and like society at large, like really wanted to facilitate that collaboration and knowledge sharing.
And would you say that collaboration is what sets Observable apart from other notebooks that people are familiar with?
I think we do have a very intense focus sort of on this like collaborative aspect and communication specifically. I think a big part of why we are in the browser and why the code is running in the browser is that it sets it up for anybody to sort of edit that code, to make sure that that code is always running live, to make it really easy to make anything interactive, to make anything dynamic. You don't have to worry about sort of setting up your local computing environment. Like, it's already running there inside of the browser, just by following the link. And so I think it all works together, like with the technology being in service of collaboration and understanding and communication.
So this takes me right to the next question I wanted to ask about. And Jeff kind of teed this up at the beginning. You and others, I guess, have written about the emergence of JavaScript in the browser as this environment for data science, which isn't where sort of data science began. So what do you think about the current and future promise of JavaScript or the browser ecosystem for data work? And how is this different from the world of Python and R and so on?
Yeah, I think it's getting better all the time, certainly. There's new technologies and new capabilities that are coming into the browser. And I think there's also like a chicken and the egg sort of problem where, if we have Python and we have sort of a language that has all of these rich tools that are built in, it's not just sort of the capabilities of the browser and the language. There's also we need to start building the tools in JavaScript in order to enable that sort of work as well. And once I think those tools have sort of become more robust and become more full-featured, then I think it's going to unlock sort of a lot more data analysis that's able to happen in the browser. I think it's hard to compete with the browser in a sense. Like, it is the lingua franca of the web. Like, it's the most natural way of representing computation. It can sort of run anywhere. But at the same time, we also have these things like WebAssembly that do let us take other languages and run those in the web. So I think I am a firm believer in, let's say, client-side computation, because that's the best way to get, 60 frames per second interaction. But I'm also a believer in sort of distributed systems and designing that appropriately. So, you don't necessarily have to download gigabytes of data into the browser in order to get your work done. I want to have a hybrid environment and things working together. I mean, I'm also very interested in sort of, languages like we were discussing earlier. So I do really love this, the more recent trend of really writing, SQL to do in-memory databases in the browser. We've been doing a lot of work with SQLite, for example. So you can take a SQLite database, put that in Observable, and you just get a database client that lets you write SQL queries. And then DuckDB, which is even newer, has sort of better performance and sort of better type support. I think I was just running into an issue with SQLite where it doesn't have great integration with JavaScript dates, so they're just represented as ISO 8601 strings, which is a little bit awkward. But I think those are some things that will improve over time. And I do really like, SQL is an old technology, but it, at the same time is such a elegant way of expressing data transformations, and so I think, to me, kind of the dream environment is being able to write SQL to do all of those data transformations and then piping that to, different visualization frameworks like Plot, or D3 or Vegalite to do your visualization.
Cool. Yeah. This echoes stuff we've been doing on the research side, but it's super fun to see you playing with this stuff in deployments and in sort of the user.
Yeah, and having something like SQL that is such a high level representation of of a query, of a data transformation, works even better with that sort of distributed environment approach, right? Because you can do work in the memory, if you could fit it in memory in the browser, but you can also do work, remotely if you're willing to set up your connection to some remote database. And there's so many different implementations these days of database that all have sort of different performance characteristics. So if you're working with time series data or whatever, you've got like timescale DB, which is really fast. So yeah, it's a good time to be doing data analysis in the browser, I'd say.
Mike, earlier you referred to the challenge of people really whipping their data into shape so they can then feed it into visualization examples or libraries such as Plot. So I'm curious, given the community that you've been helping build over at Observable, what are the kinds of data wrangling challenges you most commonly see in that environment?
One of the ones that we ran into recently, I don't know if this totally qualifies as data wrangling, but I thought it was interesting, so I would share it, actually has to do with time zones. So we were publishing a series of articles on Observable around time series analysis, and we had these data sets that were really about the electricity crisis that happened recently in Texas, where the power grid basically collapsed and people were out of power for a long time. And the interesting thing there was, we wanted to visualize these time series, but we wanted them to be in the Texas time zone. And it turns out in JavaScript, there's currently a limitation that you can either use local time, which is whatever your browser is in, that's your time zone, or you can use UTC time. And in this case, we wanted it to be explicitly in Texas time, which was usually neither of those two things unless you happen to live in Texas. And it's the sort of thing where you only really run into this problem if you're doing sort of data analysis in the web, right? Because if you're sort of a local analyst and you're interested in Texas data, you could set your local time zone to Texas, or you might just be in Texas already and you're just sharing it with other people in Texas, and that's fine. But once you do things on the web, you have to think immediately about that global audience because your readers could be in any different time zone and you want them to see a consistent picture. And so I think having that limitation in JavaScript, made it difficult for us to produce time series visualizations that were in Texas, like in the Texas time zone, independent of whatever the viewer's time zone was. Now, the good news is that they are making improvements to JavaScript. There's this temporal API proposal, which provides more explicit control of converting between time zones. But it's a little bit of a meme inside of the company about how much time we spend thinking about time zones and the challenges of converting between time zones. Because it is one of those things that you just you ignore most of the time. But when you run into it, it suddenly opens up this can of worms.
No doubt. We see date wrangling as this thing that just is a perennial trouble for everybody. And tools and libraries that help with date wrangling are just really nice little nuggets.
We've autotyping of CSV is another sort of frequent challenge that I run into, and I go back and forth a little bit on what the right way to do it is. So for the longest time, D3 and by extension Observable, which uses D3's CSV parser under the hood, didn't have any type inference in it. So you would just get strings. And the challenge is, you often don't want strings, right? You want to add things together and you don't want to concatenate them, or you want to know like when a moment in time occurred and you don't want to be parsing those date strings. You just want a date object, like whatever the natural representation is. So I introduced this like D3 autotype, which is a very like restrictive sort of type inference, where basically like, if you have an ISO 8601 string, it'll parse it as a date. If you have something that is a JavaScript's number format, essentially, like a sequence of base 10 numbers, optionally followed by a dot. I'm not going to repeat the whole regular expression right now. It's pretty long. But the point was like a very limited, because I think one of the key things I wanted was that you could understand it. The automatic type inference is that if you don't know what the rules are, it's hard to know whether it will work correctly. And so when I'm designing something that supports automatic type inference, I'm not just thinking about, what is the function called or what is the arguments in the API, but like, what are the rules? Like, if I could write it down as a sequence of steps, and are people actually likely to remember that and internalize that so that they can do it safely? Because the worst thing that can happen with automatic type inference is that people apply it and then it just corrupts their data before they have a chance to even see what's going on. And so, related to that, one of the other things that we're working on in Observable is sort of better views of tabular data so that when you do these types of transformations, you can actually see what's happening to your data. And so you don't sort of have this corruption that happens before you even have a chance to look at it.
Great. So maybe building on that and giving these experiences that you're sharing, more generally, what advice would you give to fledgling data tool builders?
Well, one of the pieces of advice that I often share is to look for sort of the smallest interesting problem. And I think, I think about this kind of from the emotional perspective of tool building, which is like when you work on like the really big problems, they take a long time, right? They take a long time to come to fruition. And sometimes when things take a long time, it can feel like you're not making progress. It can feel sort of discouraging. And eventually that, can cause you to give up. Whereas if you pick sort of these smaller problems, you can get something that sort of has an impact that you can measure and feel good about. And that sort of reinforces your desire to keep working on it. So I think when we think back about these D3 examples, one of the reasons why I was so motivated to write these examples is it's something that you can do in an afternoon and you can immediately see the impact of that, right? Like you've helped somebody solve the problem that they were, asking for help for on Stack Overflow or on Twitter. They're excited about seeing this new technique and they're sharing it with other people. That feels really good. And that's a nice sort of small chunk of work that you can do in a day and immediately feel good and get sort of that positive reinforcement. There's another kind of more subtle thing though about like these small problems. And I think that is the composability or, composition where, when you have this desire to build sort of these larger frameworks, these like more monolithic solutions, they can do a lot more, but they're harder to sort of combine together with different approaches. So again, like if we look at D3 as this suite of tools, the fact that you could sort of pick and choose each of those things independently, I think gave a lot of longevity to those ideas because they weren't all bundled together as like an all or nothing proposition. And instead you could sort of just pick one thing or pick another thing and ignore the rest. So for example, in the 10 years since D3 has existed, like the React framework has become extremely popular for building web applications. And in many ways, like the React approach to building web applications, overlaps with D3's approach of selections and sort of manipulating the DOM. But the good news is like, it's because it's not that all or nothing proposition, you can use React and you can use JSX to create your tree structure, your elements, your SVG, but you can combine that with things like D3 scales and D3 layouts to do a lot of the visualization tasks while not sort of pulling out these other aspects. So I think that really helped for D3's longevity. And I think it's sort of good from an emotional perspective as well to have these sort of more tightly defined problems that you're trying to solve rather than sort of the big ones that seem potentially appealing, but can be just harder to do.
So thank you for joining us, Mike. Again, that's Mike Bostock, founder of Observable and creator of D3. And we'll wrap up there this week. If you have a question or topic you'd like us to tackle, reach out to us at datawranglers@trifacta.com.
As always, make sure to review and subscribe to the Data Wranglers wherever you find your podcasts. The Data Wranglers podcast is brought to you by Trifacta, the Data Engineering Cloud. On behalf of Jeff Heer and the whole team, thanks for listening. I'm Joe Hellerstein. See you next time.